In this video, we're going to study the substitution rule. So the substitution rule just enables us to find antiderivatives or definite integrals of complicated functions by making them easier to handle. Let's go over the first example. Let's find an antiderivative of cosine of 4x plus 1 dx. If we were given just the antiderivative of cosine of x dx, we know exactly what this is. This is equal to sine of x plus c. But we don't have cosine of x dx. We have cosine of 4x plus 1. So what we do is we make a substitution. We set u, a new variable, equals to 4x plus 1. And the substitution rule is more of an art, and you will get used to it as you do a lot of problems. So u here, our choice of u is motivated by the fact that it is the inside function. You see here, cosine of 4x plus 1. 4x plus 1 is inside cosine. So that's something to keep in mind. Inside function. Once you make that substitution u, the next thing is you compute the derivative. So the derivative of 4x plus 1 is 4. But what you do here is what we call differential. So the derivative of u, you don't write du over dx, you write du here. So derivative of u, you can say du. And derivative of 4x plus 1 is 4. And you multiply by dx because you have the x's on the right hand side and the u on the left hand side. These are differential. Some people, the way they remember it is they write du over dx. The derivative of u with respect to x is 4, and it's kind of like the multiplication. They multiply both sides by dx to get du equals 4 dx. So that's another way of doing it. So the first step is you identify the substitution u equals 4x plus 1. Next step, you compute du. Du equals 4 dx. And then you're going to solve for dx. So by dividing both sides by 4 for this particular example, you get 1 over 4 du. So here we have that dx is 1/4 du. What do we do with that? The function that's given is, or the integral that's given is the integral of cosine of 4x plus 1 dx. So the goal here is to transform the function or the integral in terms of the new variable u without x. So this equals what? This equals the integral of cosine. Now I know what this is equal to. This is equal to u, so I'm going to write cosine of u. Instead of writing 4x plus 1, I write u because that's the substitution I made. And what's dx? Dx here is equal to 1 over 4 du. Now, if you look closely at this new integral, you don't have x anymore. So it's only expressed in terms of u. So that's what we were doing. Now, I'm going to rearrange this antiderivative. So I'm just going to write the 4x 1/4 to the front. So I have 1/4 cosine of u du. Now I can take the antiderivative. We know the antiderivative of cosine of u is sine of u and since it multiplies 1 over 4, so I'm just going to have 1 over 4. And you can verify that if you take the derivative of 1/4 sine of u, you get exactly 1/4 cosine of u. And of course, we don't forget the constant of integration, c. So that's what we get. But the very last step is to replace, because the original integral was in terms of x, not u. So once we are done finding the antiderivative in terms of u, we have to replace u by 4x plus 1. So this gives us 1 over 4 sine of 4x plus 1, and then plus the constant of integration. Now we have our final answer. And as usual, you can verify by taking the derivative of this function. You will see that you get back that original integrand. Now let's go over another example to practice more. Let's say we want to find an antiderivative of x squared square root of x cubed plus 4, x cubed plus 4 dx. Here I'm going to rewrite this integral as x squared and then x cubed plus 4 to the power of 1/2, because we had square root of x cubed plus 4. So I just replace the square root with the power of 1/2. Now, another hint here is whenever you have an expression raised to a certain power, so here we have a whole expression raised to the power of 1/2. The idea is to set u to be whatever is inside the parentheses, whatever is raised to that power. So u here is x cubed plus 4, the inside function. And you know, when you make your substitution, next step is you compute du. So du here is, what's the derivative of x cubed plus 4? Is 3x squared dx. Now we can divide by the constant 3. So when we divide by the constant 3 both sides, we get 1/3 du equals x squared dx. So on one hand we have the u's with the constant, and on the other hand we have the x's. So x squared dx equals 1/3 of du. Now what do we do with this? We had the original integral there, so this equals integral x squared let me just write it this way, x squared x cubed plus 4 to the power of 1/2 dx. I'm going to rearrange. How do I rearrange it? I'm going to take this x squared here and write next to dx. I can do that. So x cubed plus 4 to the power of 1/2, and then x squared dx. Why do I do that? Because now I can see x squared dx, this x squared dx, I can replace it with 1/3 du. And the x cubed plus 4, I can replace it with u. So this integral becomes u to the power of 1/2 times 1/3 du. And here I can rewrite again by putting the constant in the front. So I get the integral of 1/3 u to the 1/2 du. Now this is a much simpler integral, which is equal to 1/3 u to the 4 or 1/2 plus 1. That means 3/2 over 3/2, and then plus the constant c, which we can simplify. Let's go ahead and simplify this into 2 over 9 u to the 3/2 plus c. But remember, we still have to replace u by x cubed plus 4. So this becomes 2 over 9 x cubed plus 4 to the power of 3/2. And then the constant of integration. So this here is the answer. Now, to practice more, I'm going to assign some problems so that you feel comfortable doing this. So problem. Find these antiderivatives. So the antiderivative of 2x, x squared plus 3 to the power of 4 dx. So that's the first antiderivative. And the second one is the antiderivative of sine of 8x dx. So when you look at this, you can tell right away which one would be u. So a hint for the first integral, u would be x cubed or x squared plus 3, and the second one, the inside function is 8x, so u would be 8x. So start with those hints.